Our lesson for today is all about solving corresponding parts of congruent triangles. Let us recall the different triangle congruence postulates and theorems first. Again, the SAS Congruence Postulate or the side angle side. If two sides and the included angle of one triangle are congruent to the corresponding two sides and included angle of another triangle, then the triangles are congruent. For ASA congruence postulate or angle, side, and angle, if two angles and the included side of one triangle are congruent to the corresponding two angles and the included side of another triangle, then the triangles are congruent. Next, for SSS congruence postulate or the side, side, and side, if three sides of one triangle are congruent to the corresponding three sides of another triangle, then the triangles are congruent. Next, for AAS congruence theorem or the angle, and side, if two angles and the non-included side of one triangle are congruent to the corresponding two angles and the non-included side of another triangle, then the triangles are congruent. In triangle ABC, we can see the following. The right angle here is angle C, and the acute angles are angle A and angle B, while the hypotenuse, which is the longest side of a right triangle, is line segment AB, and the legs here are line segment AC and line segment BC or CB. Note, the hypotenuse is the side opposite the right angle. And for our LL congruence theorem or the leg and leg, if two legs of a right triangle are congruent to two legs of another right triangle, then the triangles are congruent. Next, for LA congruence theorem or the leg and angle, if a leg and an acute angle of a right triangle are congruent to a leg and an acute angle of another right triangle, then the triangles are congruent. Next, for HA congruence theorem, or the hypotenuse and angle, if a hypotenuse and an angle of a right triangle are congruent to a hypotenuse and an angle of another right triangle, then the triangles are congruent. And additional, we have the HL congruence theorem, which is the hypotenuse and the leg. If a hypotenuse and a leg of a right triangle are congruent to a hypotenuse and a leg of another right triangle, then the triangles are congruent. Now that we have refreshed our minds with the topic from our previous lesson, we are now ready to understand our new lesson. From our previous lessons, we have learned about congruent triangles and also the different postulates and theorems that verify the congruency of two triangles. In this lesson, we will be using this knowledge to solve for the missing parts of congruent triangles. You have learned that if two triangles are congruent, their corresponding parts are also congruent as stated by the CPCTC. This means that the sides of the first triangle have the same lengths as the sides of the second triangle, and the angles of the first triangle have also the same measurements with the angles of the other triangle. CPCTC is the abbreviation of corresponding parts of congruent triangles are congruent. We can say that triangle ABC is congruent to triangle DEF because the corresponding sides and the corresponding angles of the two triangles have equal measurements. If AB is congruent, or if line segment AB is congruent to line segment DE, then AB is equal to DE. If line segment BC is congruent to line segment EF, then BC is equal to EF. And if line segment AC is congruent to line segment DF, then AC is equal to DF. Also, if angle A is congruent to angle D, then the degree measure of angle A is equal to the degree measure of angle D. If angle B is congruent to angle E, then the degree measure of angle B is equal to the degree measure of angle E. And if angle C is congruent to angle F, then the degree measure of angle C is equal to the degree measure of angle F. Note, we know that line segment BA is the same as line segment AB, but for congruent triangles or polygons, corresponding vertices such as AD and BE must be in order. Therefore, instead of writing of line segment BA is congruent to line segment DE, we write it as line segment AB is congruent to line segment DE. Reminder, we need to take note of how the symbols are used in writing these mathematical statements. For the sides of the triangle, you have learned that a line segment is denoted using a horizontal line above its name. Example, line segment AB. But notice that this line is omitted if you're already referring to the length of the line segment or side. Example, AB is equal to 2 centimeters. And for the angles of the triangle, you use the symbol of angle before the name of the angle to refer the angle itself. For example, angle A or angle CAB. But you use the notation degree measure of angle before the name of the angle to indicate the measure of the angle. Example, degree measure of angle A is equal to 60, or the degree measure of angle CAB is equal to 60. Also, you use the symbol of this to indicate the congruency of the polygon or parts of the polygon and not to assert equality. Therefore, you cannot write line segment AB is congruent to line segment DE and AB is equal to DE, as line segment AB is equal to line segment DE and AB is congruent to DE, or angle A is congruent to angle D and the degree measure of angle A is equal to the degree measure of angle D as angle A is equal to angle D, and the degree measure of angle A is congruent to the degree measure of angle D. Before going through the examples, let's read first the steps in finding the missing parts of congruent triangles. What are the steps in solving for the corresponding parts of congruent triangles? For step 1, draw the triangles if not provided and label the parts, then write the given measurements. For step 2, verify if the given pair of triangles are congruent, if the congruency of the triangle is not yet established, and indicate the postulate or theorem. If needed, recall other concepts, postulates, or theorems to identify congruent parts. For step 3, determine the corresponding parts. And for step 4, identify the missing parts using the given parts. For our first example, let's find the measure of the indicated parts, which is line segment IN, line segment IK, angle M, and angle U. For our solution, for our step 1, the illustration is not needed since the figure is already given. And for our step 2, by looking at the marks, we can say that the two triangles are congruent by ASA postulate. And for step 3, you will see below, or you will see on the slide, the list of corresponding parts. For our corresponding sides, we have line segment MU is same as line segment IN. Line segment UG is same as line segment NK. And line segment MG is same as line segment IK. And for our corresponding angles, angle M is same as angle I. Angle U is same as angle N. And for the last pair, angle G is same as angle K. For our step 4, by CPCTC, we already claim that the corresponding parts listed in the table are congruent and have equal measurements. For letter A, if IN is equal to MU and MU is equal to 13.49, then IN is equal to 13.49. For letter B, if IK is equal to MG and MG is equal to 11, then IK is equal to 11. And for letter C, if the degree measure of angle M is equal to the degree measure of angle I, and the degree measure of angle I is 60 or 60 degrees, then the degree measure of angle M is 60 degrees. Notice that in this problem, we kept on using one of the properties of equality, which is the transitive property. And again, according to this property, if A is equal to B and B is equal to C, then A is equal to C. And for our D, if the degree measure of angle U is equal to the degree measure of angle N, and the degree measure of angle N is equal to 50, then the degree measure of angle U is equal to 50. Now, if you want to prove that, let's have our solution. For our solution for letter D, the degree measure of angle I plus the degree measure of angle N plus the degree measure of angle K is equal to 180. Since the sum of the interior angles of a triangle is always 180 degrees. So now, let's substitute the value or the degree measure for the respective angle. The degree measure of angle I is 60 plus, since we're looking for the degree measure of angle N, plus the 70, which is the degree measure of angle K, is equal to 180. So now, let's combine similar terms. We're going to transpose 60 and 70 to the other side. So it will become the degree measure of angle N is equal to 180. From positive 60, it will become negative 60 or minus 60. And then from positive 70, it will become negative 70, or in terms of operation, that is minus 70. Therefore, the degree measure of angle N is 50 degrees. Since the degree measure of angle N is equal to 50, then the degree measure of angle U is 50. For our second example, given the triangle HOT is congruent to triangle PIE, and HO is equal to x plus 3, OT is equal to 7x minus 1, HT is equal to 5 or is equal to 5x plus 2, and PE is equal to 2x plus 5. Let's find x, HT, and IE. For our solution, for our step 1, the given may be illustrated as on the slide. For our step 2, we may skip this step since the congruency of triangles, triangle HOT and triangle PIE is already established, which is SSS. And for our step 3, since we are looking for the other sides of the triangle, then we will just determine the corresponding sides. We have line segment HO is same as line segment PI. Line segment OT is same as line segment IE. And for our last pair, line segment HT is same as line segment PE. And for our step 4, let's solve for x, HT, and IE. Since HT is same as line segment PE, then HT is equal to PE. From the given, HT is equal to 5x plus 2 and PE is equal to 2x plus 5. So therefore, 5x plus 2 is equal to 2x plus 5. And after this, let's combine similar terms. So we're going to transpose 2x to our left side and we're going to transpose positive 2 to our right side. So it will become 5x, and from positive 2x, it will become negative 2x or minus 2x is equal to 5. From positive 2 now, it will become negative 2. And 5x minus 2x, we have 3x is equal to 5 minus 2 is equal to 3. And let's apply the division property of equality. So we're going to divide it by 3. since we're looking for the value of x. So 3x divided by 3 is x, or 1x, and 3 divided by 3 is 1. Now, our value for our x is 1. To solve for ht, we just substitute the value of x in 5x plus 2, since ht is equal to 5x plus 2. So if we substitute the value of x, so since our x is 1, so it will become ht is equal to 5 times 1, which is the value of our x, plus 2. And then 5 times 1 is 5, then plus 2. Therefore, our value for our ht is 7. And to solve for IE, we have to substitute the value of x in 7x minus 1. IE is equal to OT, and OT is equal to 7x minus 1. Then IE is equal to 7x minus 1. So we substitute the value of x to 1. So we have now IE is equal to 7 times 1 minus 1. So 7 times 1 is 7, minus 1, we have 6. Therefore, the value of our x is 1, the value of our ht is 7, and the value of our IE is 6. For our example number 3, line PN is the perpendicular bisector of line segment AE, where line segment PE is equal to x plus 3, AN is equal to 6, and EN is equal to 2x minus 4. Find the perimeter of triangle EPA. For our solution, for our step 1, although an illustration is provided, we may add markings to easily determine the congruent parts. As stated in the given, line PN is perpendicular bisector of AE. Therefore, point N is the midpoint of line segment AE, and we can say that line segment AE is congruent to line segment EN. And by reflexive property, line segment PN is congruent to line segment PN. Take note that line PN is perpendicular to line segment AE. Then, the angles formed, angle ANP and angle ENP, are both right angles. Thus, triangle PAN and triangle PEN are right triangles. And for our step 2, looking at the markings, we can say the triangle PAN is congruent to triangle PEN by LL theorem or leg and leg theorem. For our step 3, looking at the corresponding sides and the corresponding angles, for our corresponding sides, line segment PA is same as line segment PE. And line segment AN is same as line segment AN is same as line segment EN. And line segment PN is same as line segment PN as by reflexive property. And for our corresponding angles, angle PAN is same as angle PEN. Angle ANP is same as angle ENP. And for our last pair, angle NPA is same as angle NPE. And for our step 4, let's find the perimeter of triangle EPA. Notice the triangle EPA is an isosceles triangle whose legs are line segment PA and line segment PE, and whose base is line segment AE. To get its perimeter, we just need to add these sides. The perimeter of triangle EPA is equal to PA plus PE plus AE. Since the lengths of the sides are not given yet, we will still have to solve for their measurements using the triangle congruence. The congruence of triangle PAN and the triangle PEN is already established in step 2. Now, we can solve for their parts. If line segment AN is same as line segment EN, then AN is equal to EN. From the given, AN is equal to 6 and EN is equal to 2x minus 4. And AN is equal to EN. So let's substitute the value. So we have now 6 is equal to 2x minus 4. Let's combine similar terms. So we're going to transpose negative 4 to the left side, and it will become now positive. So it will become 6 plus 4 is equal to 2x. 6 plus 4 is equal to 10. And we have now 10 is equal to 2x. After that, we apply the division property of equality. We're going to divide it by 2. So 2x divided by 2 is x, and 10 divided by 2 is 5. So we have now 5x, or x is we have now 5 is equal to x, or x is equal to 5. Next, if AN is equal to 6, then NE is equal to 6. By addition segment postulate, AE is equal to AN plus NE. Therefore, AE is equal to 6 plus 6. And the value of AE is equal to 12. Next, side PA is equal to PE, and PE is equal to x plus 3, and x is equal to 5. So let's substitute the value of x. So we have PE is equal to x plus 3, and if we substitute the value of x, we have 5. So it will become now PE is equal to 5 plus 3. So therefore, our line segment PE is equal to 8. Since PE is equal to PA, the value of PA also is 8. Now, we can get now the perimeter of triangle EPA by substituting the value of our PA, PE, and AE. Again, the value of our PA is 8, the value of our PE is 8, and the value of our AE is 12. So therefore, the perimeter of triangle EPA is 28. Next, for example number 4, given that line AB is the angle bisector of angle CAD, angle ACB is congruent to angle ADB, and CA is equal to x plus 6 and DA is equal to 2x minus 3. So let's find DA. For our solution, for our step 1, the given on the slide or the given above may be illustrated on the slide. So we have angle ACB is congruent to angle ADB as stated in the given. Next, angle CAB is congruent to angle DAB according to the definition of angle bisector. And line segment AB is congruent to line segment AB by reflexive property. And for our step 2, from the illustration we made, we can say that the triangle CAB is congruent to triangle DAB by AAS theorem. For our step 3, we can see that only the sides of the triangle are given. Then we will list only the corresponding sides. So for our first pair, we have line segment CA is same as line segment DA. For our second pair, line segment AB is same as line segment AB by reflexive property. And for our third pair, line segment BC is same as line segment BD. Now, let's proceed to our step 4. For our step 4, let's find DA. Since line segment CA is same as line segment DA, then CA is equal to DA. And CA is equal to x plus 6, while DA is equal to 2x minus 3. To solve for x, since CA is equal to DA, so let's substitute the value. We have now x plus 6 is equal to 2x minus 3. And after that, let's combine similar terms. So we have now 6 plus 3 is equal to 2x minus x. So 6 plus 3 is 9 and 2x minus x is 1x or x. So therefore, we have 9 is equal to x or x is equal to 9. Solving for DA, we just need to substitute the value of x to the expression of 2x minus 3. Since DA is equal to 2x minus 3, so we substitute the value of x to 9. So we have now 2 times 9 minus 3, 3. So 2 times 9 is 18 minus 3 is equal to 15. Therefore, DA is equal to 15. Next, for our example number 5 or for our last example, find the values of x and y if the degree measure of angle URO is equal to 110 and the degree measure of angle FOY is equal to x and the degree measure of angle OYF is equal to y and the degree measure of angle ROU is equal to y plus 10 or ROU is equal to y plus 10. For our step 1, the illustration is not needed since the figure is already given. For our step 2, looking at the markings, we can see that one pair of angles, which is our pair of angles is angle OFY and angle ORU, and our pair of sides, which is line segment FO and line segment RO, are congruent. Therefore, in addition, another pair of congruent angles can be observed, which is our vertical angles, which is angle FOY and angle ROU. Therefore, the triangle FOY is congruent to triangle ROU by ASA theorem. Now, for our step 3, based on the given and unknown, we may list only the corresponding angles. We have angle FOY is same as angle ROU. Next, angle OYF is same as angle OUR. And for our last pair, angle YFO is same as angle URO. Now, let's proceed to our step 4. Since the angle FOY is same as angle ROU, then angle FOY is congruent to angle ROU. Thus, the degree measure of angle FOY is equal to the degree measure of angle ROU. If the degree measure of angle FOY is equal to x, and the degree measure of angle ROU is equal to y plus 10, then x is equal to y plus 10, that will be our first equation. We can say that angle YFO is congruent to angle URO because angle YFO is same as angle URO. Then, the degree measure of angle YFO is equal to the degree measure of angle URO. If the degree measure of angle URO is equal to 110 degrees, then the degree measure of angle YFO is equal also to 110 degrees. Now, we add the angles of triangle FOY and equate it to 180. So we have now the degree measure of angle FOY plus the degree measure of angle OYF plus the degree measure of angle YFO is equal to 180. Recall that the degree measure of angle FOY is equal to x, and the degree measure of angle OYF is equal to y, and the degree measure of angle YFO is equal to 110 degrees. Substituting the value of each angle, we have x plus y plus 110 is equal to 180. Therefore, this will be our second equation. Now, let's substitute the value of x from equation 1 to the x of equation 2. It will become now y plus 10 plus y plus 110 is equal to 180. And after this, combine similar terms. So we're going to transpose positive 10 and positive 110 to the right side, and it will become negative. So y plus y will become 2y. And then 10 plus 110 is 120. And if we transpose that to the right side, it will become 2y is equal to 180 minus 120. So therefore, we have 2y is equal to 60. And after this, we use division property of equality so that we can find the value of y. We divide it by 2 divided by 2. 2y divided by 2 is y, and 60 divided by 2 is 30. So that is the value of our y. And to solve for x, we will substitute the value of y in equation 1. Since our equation 1 is x is equal to y plus 10, and if we substitute the value of y to 30, it will become now x is equal to 30 plus 10. And our x is equal to 40. Therefore, the values of x and y respectively is 30 and 40. So I hope, class, you understand how to solve corresponding parts of congruent triangles. Thank you for listening.